Alright, now that we know in theory how we can implement this function, let's actually put it into practice. First of all, let's quickly verify that this code still runs when we run our plugin. So I'll just quickly create a rectangle here in our artboard, which we now even already know that it's an artboard at, say, coordinates 2020, with a width of 20, a height of 20, and as a hex color, let's use red again. Save the plugin, wait a few seconds so that XD has a chance to reload the plugin, and now run it. And as we can see, the code inside our function still runs, which is great, and which also means that we can now go ahead and actually implement our function as we had planned it in our Excalitro document. Of course, since the artboard won't change inside this function, we can actually calculate the rectangle width and the rectangle height right here, outside any loops or anything like that, so that we don't constantly re-evaluate this unnecessarily. So we'll just say constant rectangle width, or yeah, let's just write it out. Rectangle width equals the artboard dot width, which actually exists, which is great, divided by our number of subdivisions, as discussed previously. Let's also do the same, and I will quickly decrease the code size a little bit, just so that more fits onto the screen. I will increase it once again as soon as we're done. Const rectangle height, as discussed, this is equally easy, artboard.height divided by the number of subdivisions. So no bigger problems there. And now what we actually need to do is we have to iterate through all the different rows and columns. So basically through every field in here, so to speak. And to do that, it's actually pretty simple. We just use a fairly standard JavaScript for loop. And we first of all iterate through all the rows, but really it doesn't matter. We begin at 0. We want 0-based indexing, as we've seen in our document. Then we just see that row stays smaller than the number of subdivisions, and row gets increased at the end of each loop. And of course, if you now think about it, this will exactly achieve iterating through all the rows, because we start at 0, so we begin at 0, which is still smaller than 3 in our example right here. So 0, we iterate through 0, we have row 1, we iterate through 1, still smaller than our number of rows. 2 is also still smaller than 3, and then we as soon as we reach an imaginary column 3, our loop aborts or just ends, because of course 3 isn't smaller than 3 anymore, so we won't execute that anymore. And we can do exactly the same with our number of columns. So for let col for columns equals 0, col smaller than subdivisions, and who would have guessed it, col increase columns, do something in here. And now actually we already iterate through all these fields right here, all these cells in this tabular structure, if you want to think about it in that way. As we've discussed, all we have to check for now is that the sum of row and col are not even, or in other words, they are odd. So all we need to do is we have a simple if condition. Makes sense, right? We want to check for something, and we say if the row plus the column modulo 2 doesn't equal 0. So for those of you who are unaware, modulo basically returns the remaining part in an integer division. So if you think about it, for example, 3 divided by 2 would of course be 1.5, but maybe you remember this back from elementary school. There was also a way where you could say it is 1 with a remainder of 1. So in that sense, if we divide some odd number by 2, there will be a remainder that's not 0, but if we divide any even number by 2, of course it's perfectly possible to represent this with a single integer result. So for example, 4 divided by 2 is just 2 with no problems at all. And in that way, we can easily check if a number is even or odd by checking if modulo 2 is equal or not equal to 0. So in that sense, we just check that it, in this case, isn't equal to 0, which means it is odd. And if our number is actually odd, all that's left to do is to create our rectangle. And just to make it a little bit easier to read, we'll explicitly calculate our x and y coordinate. Before calling create rectangle, we could just as well do this in line, but it's just a little bit more readable this way, in my opinion. So we just say const x equals rectangle width times columns, as we've discussed in our previous video. Y coordinate follows the same principle, rectangle height times row. And now all that's left to do really is to call create rectangle. And of course, we still have to pass our arguments once again, but we now have all these values defined already. So we take our artboard, we have the x coordinate, which is just x, we have our y coordinate, which is y, we have our width, which is our rectangle width, we have our height, which is our rectangle height, and last but not least, we have to specify some color. And let's make this like a classic chessboard and just make it black and white. And if I now save this and we then go back inside Adobe XD, I'll quickly make the code a little bit bigger so that you can read it a little bit better again and make VS Code full screen. So I'll give you just a second. You can pause the video now and just write this code if you weren't able to read it before. But now if we can go back inside Adobe XD and we select this artboard, hopefully we will actually get our checkerboard pattern. So are you ready? Let's try it. I click it and it works, as you can see. And also, if we now take a look, we have 1, 2, 3, 4, 5, 6, 7, 8. So exactly our 8 divisions that we've specified in our main.js file. If we now were to change this and, for example, say only make 3 subdivisions, as we had discussed previously, and I will just create an additional artboard where we can do that, and I run our plugin once again, you can see that this works perfectly as intended. And with that, we now really created the basic functionality of our plugin, which of course is great. And in the next video, we're actually going to take a look at reintegrating our panel, which still lets us enlarge a rectangle, which of course could also be used in conjunction with our current functionality, but it's not really what we want, of course. So we will take a look at how we can reintegrate, so to speak, our command, which currently just uses a constant value that I will reset to 8 now, of subdivisions, and instead let the user specify within the plugin UI the number of subdivisions they want, and then we can create some generative art by combining multiple subdivision values in various artboards. For now, however, this concludes checkpoint number 6. So in case you haven't been able to follow along, you can just copy the code from there. And with that, I'm looking forward to, in the next video, create some UI around it. But for now, thank you very much for watching.